Hello everyone, today we're going to talk about Venn diagrams, and there's a picture of the man himself. That is Mr. Venn, who invented this stuff that we're going to talk about today. We use Venn diagrams to display relationships between events. You're going to find them to be very helpful in calculating probabilities. You've seen these before, so we're just going to go through this pretty quick. This is an example of a Venn diagram. The area that's shaded would be the complement of A, because remember that the complements are the part that is not in A. So A is the circled part that's white, and then the complement of A would be all of the shaded part. When you're drawing a Venn diagram, you have two circles, one for A and one for B. A or B would mean that it could either be an A or B, which means it would cover all of those two things, so they would be put together like that. If you have disjoint events, that means there's no overlap. So A and B don't overlap. They're mutually exclusive. So a probability of A or B would simply be the probability of A plus the probability of B. If you have non-disjoint events, so in this case they do overlap. If we want to find the probability of A or B, then we would need to add the probability of A plus the probability of B, but then we have to subtract that middle section that is both in A and B. And you can see why we have to do that. If we're adding all of A, so say A had 50 things in it, and B had 40 things in it, then there was going to be a certain number of things that would be in both A and B, and they would wind up being counted twice. So we have to subtract them. And the Venn diagram helps you see that. So here, let's say we're given an example. We have people taking statistics, people taking calculus, and people taking computer science. The part that's shaded would be the people who are taking statistics and computer science and not calculus. Alright, so you need to be able to look at that picture and see that. The shaded portion, those are people that are both in the statistics circle, they're also in the computer science circle, and they're not in the calculus circle. So it satisfies all three of those requirements. What about this one? This one, you get the idea of what's going on here. These would either be calculus or computer science, because it's all of the calculus people or all of the computer science people, but none of the statistics people. What about this one? Slightly different than the last one. In this case, we have they're either in statistics or computer science, because it covers those two circles, and not calculus, because they're not in that circle. And one more. What's this one going to be? These would be people who are in statistics and not computer science or calculus. All right, because it's not in either one of those. You can see the computer science or calculus are the two non-shaded parts. The shaded part would be people in statistics and both of those other ones. Now, a lot of times in this situation, you're given a data set, you're given numbers, and you're being told how many people are in each of the regions on the Venn diagram, and then you're asked to do a probability, ask a probability statement based off of that. So in this case, the question would be, what's the number of people that are taking statistics or computer science? Well, in that case, we would add up all the people who are taking statistics or computer science. It would be the 30 plus the 20 plus the 10 plus the 10, so that's 70, plus another 20 plus another 80 is 170. Statistics and computer science. Well, in this case, they have to be taking both statistics and computer science. That would simply be the 20. It would be the two 10s, because those two are in the 10. They're both in the computer science and statistics region. Statistics or computer science and calculus. Right, so it's either statistics, so all the people in the statistics group, or the people who are taking computer science and calculus. That's going to be the 30, the 20, the 10, the 10, and the other 20. Now, that leads us into our final little topic we're going to talk today, and that's simulations. So let's say we have a fictional student named Corey, and he rolls a dice 30 times. How often does a number of 2 or less appear? Now we could actually go out and roll a die 30 times and keep track of that, or we can use a simulation on our calculators to help us figure this out without having to actually go out and roll the dice. So we're going to use our graphing calculators. So press pause if you need to, but then get your graphing calculators out. First thing we're going to do is we're going to create the random numbers. The way you create random numbers on your calculators is you find the math button. It's underneath the green alpha button, so you press math. Go over 4 steps to PRB, which is probability. Underneath that, number 5 is rand int, so we would hit that button. Now if we're going to do a random integer between 1, 6, so the comma's up above the 7, so we're saying we're going to pick a random integer between 1 and 6 to simulate the dice, and then comma 30 times. And we hit, and we're going to store that. See the little arrow there? We're going to store that into list 1. So store is directly above the on button, and then we're going to hit that and then press second list 1, and that then is going to store our data into our list 1. The next thing we're going to do is we're going to organize our list. So we're going to take list 1, and we're going to convert any number that is above a 2 is going to get a 0 value. So 3, 4, 5, 6, we're going to convert all those into zeros. 1s and 2s, we're going to convert them all into 1s. So the way you do that is you do the keystrokes. You do second list 1. Now, that's a less than or equal sign, and here's how you find that. Second, and then the math button. It's the blue button that says test, so second test, and then the 6th one down is the less than button, less than or equal to. So you do list 1, less than or equal to 2, store that, there's the arrow again, store into list 2. And you can see that it converts everything that's above a 2 becomes a 0, and everything that's a 1 or a 2 becomes a 1. And the reason we do that is because now we can do the sum command on your calculator. Okay, the way you find the sum command is you do second list, which is directly above the stat key, second list, go over to math, and then the 5th one down is the sum. So you can do sum of list 2, and what it does is it adds up all of those 1s. Now remember that the 1s represented the 1s and the 2s, and so you get a sum. Now your sum is going to be different than mine because everybody's simulation is going to be slightly different. But on this on this screen, we got 11 out of 30 were 1s and 2s. So that's our simulation of rolling the dice. So during the last simulation, Corey rolled, he didn't actually roll it, we used a calculator to simulate it, numbers 2 or less 11 times, which worked out to 36.7%. Is this what you expected? Well, we know hypothetically that a 2 or less, 2 or a 1, should occur 33% of the time because it's 1/3 of the dice. So it's not quite what we expected, but it's pretty close. So why wasn't it exactly 10? Because we didn't roll it enough times. 30 times is not very many, and remember that in the short term, we don't know what's going to happen probabilistically, predictably. We don't know what happens in the short term, but in the long term, we would expect 33%. So if we were to do this 300 times, so here's 300 trials, 1/3 of 300 is 90, and you can see that that's exactly what happens. Now you can try this on your calculator, and you may not get 90, but I would anticipate you getting something very, very close to 90. We can also do this for tossing coins. If I wanted to toss one coin, I would do a random integer from 0 to 1. 0 would be heads, 1 would be tails, or vice versa. You can choose. If I wanted to toss 2 coins, I would do a random integer from 0 to 1, and I would do it twice, and that represents 2. So if I get 0, 0, that's heads, heads. If I get 1, 1, that's tails, tails. Next up, I could do 4 coins, or I could do as many coins as I wanted to. And I could even do a sum of that random integer and then figure out, and that would tell me how many heads. If we let heads equal 1s, then the number of heads would be added up, and that could do it. So there's different ways you can do simulations on your calculators, and we're going to be doing a lot of these in class as well.